Hi folks, this is number 11 from page 480 from the Unit 7 assignment. So here they're asking us to find the vector and parametric equations of this plane given in Cartesian form. Okay, so in order to get the vector and or parametric equation, we know we need two direction vectors and we need a point on the plane. So I would say the easiest way to do this is to determine 3 points, and then from there we can create our two direction vectors. Okay, so I'm going to take this equation here and I'm actually going to rewrite it in this form here with the constant term on the other side, and I'm going to use an old trick that you would have used back in grade 9 or 10 to find intercepts, okay, to help you determine information about a line. So when you were working with a line in 2D, you could determine an intercept by setting the other variable to 0. So here I'm going to determine the x, y, and z intercepts by setting the other two to 0. Okay, so first I'll set y and z equal to 0. So my first point, I'm just going to be left with 3x equals -6. So x is equal to -2. So that means the point -2, 0, 0 is on the plane. Then for my second one, I'll set x and z equal to 0. So I'm just left with the y variable. Okay, and I guess they wrote this equation, so this worked out quite nicely. So here we've got -3, and so 0, -3, 0 is a second point on this plane. Okay, and a third point, again, I'm going to set x and y equal to 0 and solve for z. So I'm just left with -z equals -6, so z is equal to 6. So here we have 0, 0, 6 is a third point on this plane. Okay, so now from here I can determine my direction vectors. Okay, so I'll call my first one vector A. And again, this is where anytime you're working with vector parametric equations, there's lots of different forms that this equation can take. So yours might look different. The one from the textbook might look different. I'm just going to use this one here. So here I'll take the vector joining these 2 points. So 0 minus -2 gives me 2. Here, -3 minus 0 just gives me -3, and 0 minus 0, 0. So there's my first direction vector. And now I'll find a second direction vector by joining these 2 points. Okay, so 0 minus -2 is 2, 0 minus 0, 0, and 6 minus 0 is 6. Okay, so these are 2 direction vectors. I can even change this to 1, 0, 3 if I wanted to, since I need any vector in that direction. And so now again I could pick any one of these 3 points, so I'll pick this first one here. So one possible vector equation for this plane would be -2, 0, 0 plus s times 2, -3, 0 plus t times 2, 0, 6. Okay, so again you can see that just by taking different combinations here I could get something that looks very different but would be equivalent to this equation here. And so now if we just rewrite this in parametric form, we've got -2 plus 2s plus 2t, and then y is equal to 0 minus 3s, so -3s, and again plus 0t, so nothing there, and then z is equal to 0 plus 0s plus 6t. Oops. There we go, 6t, and there we go. So this is one possible scenario to solve this problem. Okay, but as you can see, just choosing different combinations of points to create my direction vectors, I could have chosen different x's and y values to determine a z value, so this could have looked very different here. Okay, that's it for this one.